All right, John, so we are moving on to the next chapter. This is chapter 14, Trig applications, okay? So this chapter consists of, let me see, 4 different things, 3 different equations that you need to know, but what is great about this whole entire chapter is that you don't have to memorize any of these equations. They are all on your reference sheet. So if you have a reference sheet out in front of you right now, that's awesome. If not, pull one up online. And I want to show you. In chapter 14, trig applications, we're going to be talking about the area of a triangle, which is this one, law of cosines, and then all the way down here, law of sines. So those are the 3 equations that we're going to be using in this chapter. Like I said before, it's awesome because you don't actually have to memorize them. They are given to you. Okay, so let me just move this out of the way for you, and then the first equation that we're going to talk about is law of cosines right here. So let's look on the next page. And I want you to take a look at this equation really quickly, and I want you to tell me what it reminds you of when you look at this. C squared is equal to a squared plus b squared. That should remind you of the Pythagorean theorem. Now, what did we use the Pythagorean theorem for? Pythagorean theorem was used to help us find the missing sides of a right triangle. Okay, so Pythagorean theorem only worked if we had a right triangle. So that was great. It helped us find the missing sides. You know that this side had to be A, this side had to be B, and this side had to be C. Okay, but like I said, it didn't work if you have any other kind of a triangle. If you have a triangle like this, PT does not help us. So the concept that we're talking about today, law of cosines, is pretty much a brand new equation for you to use. It does the exact same thing as the Pythagorean theorem, except for you can use it for any kind of triangle. So now you can use this equation for a triangle that looks like this. And the way that we did that, you had to like sort of adapt the Pythagorean theorem just a little bit more by adding this stuff at the end of it. Okay, so the reason why we didn't teach you this a long time ago was because you need to know trig in order to use this equation. Okay, so the law of cosines is used the same way as Pythagorean theorem. You can use it to find missing sides of a triangle. And actually, there's another added way that we can use it. We can actually use it to figure out what one of the angles of the triangle are if you know all of the sides. So let me just go through this really quick. C, A, and B, they're all sides of a triangle. Okay? And then the capital letter, that represents an angle. Okay, it's the same thing as it always was before, except for here is the one thing that I want you to notice. If I label this triangle ABC, ABC, okay, little c represents the side across from vertex C. A represents the side across from vertex A, and B represents the side across from vertex B. The only important thing that I want you to recognize about this equation is you know how in Pythagorean theorem it always mattered where the C was? The C had to be the hypotenuse. Well, in this case, the C, the number that you start with out front, has to be equal to the side that's across from the angle. Okay, see how that's little c and that's big C? That always has to match. Now, a couple of the kids on the day that we went over this in class, they were kind of getting a little bit confused because they said, well, look at the equation right here. On your reference sheet, it's different. It starts off by saying a squared is equal to b squared plus c squared minus 2bc cosine of a. And that's when I stopped and I told them that they were all 9th graders, and at this point in their lives they should be able to read an equation and know that you can replace certain things as long as, you know, things stay consistent. So the only reason why it was different is because, look, you have side length A right here, but you have angle A right there. So that's why we're allowed to write that. So you could do c squared is equal to a squared plus b squared, blah, blah, blah. Or a squared is equal to b squared plus c squared, blah, blah, blah. Or the last one that you could do b squared is equal to a squared plus c squared minus 2ac cosine of b, because the b is what we started with. Okay, so the point of that is that it doesn't really matter as long as this angle, whatever angle you have right here, that's the side length that your equation starts with. Okay, but besides that, this equation is awesome because you don't have to memorize it, and all that you're going to use it for is to plug in values and then solve. That's it. So let's see. You use the law of cosines to find a missing side if you're given side angle side. So let me draw a triangle for you. If you know that you have side angle side, so let's say 10, we're going to say this is 45 degrees, and you know that this is 12. If you have side angle side, you can use the law of cosines to figure out what this side is equal to. And the reason why is because the angle that is in your equation is the one that's going to be across from this side length. Okay? Or you can use it to find a missing angle if you already know what all of the sides are. And you're going to get better at this once you do more practice. So if you know that this is a 12, a 13, a 14, you can use it to figure out a missing angle. And in this case, it doesn't matter which angle you use because, like say I choose this angle, all I'm going to do is in my equation, I'm going to write this side length first. If I wanted to use this angle or find that angle, I would use this side length first, and if I wanted to find that angle, I would use this side first. Okay? So you might want to write this down. Use it to find a missing side, giving side angle side, or a missing angle if you know all the sides. Okay? Alright, so this is an example problem. Find t to the nearest integer. So, in this case, we have side, angle, side, and I'm going to use it to find a missing side. So, remember that because we have this angle given to us, the side across from it is what's going to come first in our equation. Okay? So the equation goes like this. Now, I know that we use a, b, and c, but it doesn't really matter. So a squared is equal to b squared plus c squared minus 2bc cosine of a. And the reason why we call it the law of cosines is because there's a cosine right there. Okay? So, if this is the angle that we're going to use, the side across from it is what it has to come first. So t squared is equal to. Now, it's kind of the same thing as the Pythagorean theorem. Once you have that one in the right spot, it doesn't matter which other side comes first or second. So I'm going to just do 11 squared plus 12 squared minus 2 times 11 times 12 cosine of 120. Okay? Now, there's two different things that we can do with this equation, right? We can find a missing side, or we could find a missing angle. In this case, we were finding a missing side. And that is actually awesome because t squared is equal to this whole thing. So you know what we're going to do? We're going to type this whole thing into our calculator and let the calculator do the work for us. So I'm going to type in 11 squared. Make sure that you are in degrees when you're doing this because I have cosine of 120 degrees. So I have 11 squared plus 12 squared minus, now all of these numbers are being multiplied by each other, so the way that I like to do it is type into the calculator minus and then put all this stuff in parentheses just so that the calculator doesn't get confused with what you're trying to do. 2 times 11 times 12 times the cosine of 120, close the parentheses, hit enter, that is what t squared is equal to. 397. So we're finding t to the nearest integer. T is equal to the square root of that, which is, now on the Regents exam, if you want full credit, you need to write out a couple of decimal places first, 19.9248, and then you can round it to the nearest integer after that. So t is equal to 20. That's going to be my final answer. Okay? So not too hard. This is actually the easiest part, is when you're solving for this side length right here and you can just type in everything into your calculator all at once. Okay? Let's try another question. Find to the nearest integer the length of the base of an isosceles triangle if the measure of the vertex angle is 84 degrees 15 minutes and the measure of each leg is 12. Now, there's a lot of stuff going on. This is definitely a word problem. So what I'm going to suggest is that we're going to draw a picture. Except for, before I draw a picture, I want to make sure that you're comfortable with this part. 84 degrees 15, this sign means minutes. I'm not sure if you ever learned that, so I'm going to go over it really quick. 15 minutes is kind of like decimal form of a degree. So we have 1 degree. And within every single 1 degree, there's 60 minutes. It's kind of like there's 60 minutes in an hour. There's 60 minutes in 1 degree. So you have a button on your calculator. Right here where it says apps, above it says angle. So you can type all this stuff in using that button. So let's see. If I'm going to type in 84 degrees, I'm going to go 84, second apps. That'll bring me to my angle thing. See how there's a degree symbol right here? Hit enter. 84 degrees and then 15 minutes. 15, second angle, right down to the second line that has the minutes. Hit enter. Let's see what that is as a decimal. As a decimal, that's 84.25 degrees. And the reason why is because that's 84 degrees and we have a total of 15 minutes out of 60 total minutes that we could have. So what's 15 divided by 60? 15 divided by 60 is 0.25. So this is 84.25 degrees. Sometimes you're going to get an answer that's just in normal degrees, and then the question asks you, please, put it in terms of degrees and minutes. If you want it in terms of degrees and minutes, I'm going to go the other way for you. If we had 84.25 and you wanted it to go back into degrees and minutes, you go back to the same menu, second apps, and then right here on the 4th line it says DMS, and that doesn't mean Doyle Middle Schools. It means degree, minute, or degrees, minutes, seconds, because there's actually, it breaks down even further from degrees into minutes and then into seconds. But hit that button. So we're going to take 84.25, put it into degrees, minutes, and seconds, hit enter, and it breaks it down into 84 degrees, 15 minutes, 0 seconds. Okay, so that was just a quick tutorial about degrees, minutes, and seconds for you, just in case you see it on your final exam. That's in the angle menu or button right there. Okay, I'm going to stop this right now and start another video for you. Okay.